Hi, I'm Miguel, a developer relations engineer on Android. For this workshop, I'm going to walk you through building an adaptive layout with SlidingPaneLayout. Devices come in a variety of shapes, sizes, and form factors, and you should design your app to run on all these devices. Some devices like foldables have multiple you could run on. So from phones to foldables, tablets to desktop, your app should have an adaptive layout to optimize the experience on all these different screen sizes. So today we're going to look at one way to do that by taking the Sports app and implementing a list detailed layout with SlidingPaneLayout. So let's get started. So let's take a look at the code. So the Sports the app consists of two screens. The first screen displaying the sports list here, the second screen displaying the selected sports news. So the app has one activity with several fragments, including the sports list fragment, which is the list of which contains a recycler view that shows a list of sports news, and then the sports news fragment has the full news item with image banner and news text. So the code lab goes into more detail about the architecture overview of the other files as well, if you want to check that out. So let's deploy the app to see how it looks. So here we go, deploying the app. So there are instructions on how to set up an emulator in the code lab. I won't go through that here, but feel free to read through those instructions if needed. So I'm actually running a resizable emulator, which is a new feature available on Android Studio. It lets you toggle between different device sizes, there's different device types. So like phone, foldable, tablet, desktop, all within the same emulator, which is really convenient. Makes it easy to both validate your layout at design time and test the behavior at runtime using the same reference devices. So let's take a look at the Sports app right now. So on the phone, we notice a very standard layout for the phone. Item, it opens the details view. We can go back, click on another item, opens the details view as well for the other item. We can go back and let's update this to tablet. So we're going to resize to tablet. Notice how the layout is a little stretched, so it's not making the best use of space here. So each item is kind of stretched across the full screen, and it's not really needed. So we have more room now to display both the list items on the side and the details next to it. So this is what we call a list detail pattern. So we can see here in the code lab. So we go back here to the list detail pattern, and for our sports app, we want, this is kind of what we are hoping to get to by the end of the code lab. The list on the left and the details on the right using SlidingPaneLayout. However, we want to note that for smaller screen devices, we don't want it to display side to side because it'd be too cramped. So SlidingPaneLayout actually makes it really easy to automatically support both depending on screen size. So let's get started with implementing SlidingPaneLayout. So we'll go back to Android Studio. So I've already added the library dependencies here. So you'll see that down here using the latest SlidingPaneLayout version. And so now that we have that, we are going to go to our sports list fragment XML. So we're going to switch to code over here. So notice that our root element is a frame layout. What we want to do is update this to layout. So we are going to update this to a sliding pane layout. Oops, that's not the right one. So we want to update this to sliding pane layout. Perfect. And then that got messed up because I updated that. So we just update that there. All right, and the next thing that we want to do is we want to add an ID tag and set it as sliding pane layout. So D tag, and then we are going to name it sliding pane layout. Perfect. And then the next thing we want to do is under the recycler view that we see here, we're going to add a new pane. So this is going to be a container view. So this is what I accidentally added earlier. So the fragment container view. So for now, for layout width and height, we're just going to have it match parent, and we will update that in a second. And then we will add our closing tag here. And so like what we did above, we're going to add an ID. So Android ID, we are going to set as, what are we going to set this as? A detail container. So detail container. And then we are also going to specify it as a news detail fragment for the name attribute. So for name, we're going to specify this as news detail fragment here. So that is what we want to see. Great. So now that we have that, we need to update the layout width attribute. So sliding pane layout uses the width of the two panes to determine when to show the two panes side by side. So first in the recycler view, we're going to update layout width to 550 dp, and then we're going to update the fragment container view to 300 dp. So if we go back to the code lab, we can kind of understand why we chose those values. So the breakpoint for the expanded class between medium and expanded class is 840 dp. So we are slightly above that, and that's just saying like at this breakpoint we want this new layout to appear. So that's why we chose those values. So the 550 plus 300 equals 850. So right above the recommended breakpoint. So now that we have that, let's deploy this to the emulator. So that is being deployed to the emulator. Okay, so this is looking a little bit better. We see our list and our detail pane at the same time, which is great. But if we notice, the detail pane now has is not taking up the kind of full width. So it's kind of awkwardly just taking up the 300 dp specified in the width. So to get around that, we are going to use the layout weight attribute. So in our fragment container view, we are going to specify a new layout weight, and then we're going to specify that as 1. So if we do that and then redeploy it, it should work. So for views that don't overlap and are side by side, sliding pane layout supports the use of layout width on the child view to determine how to divide the leftover space after the measurements are complete. So now we see it's updated and the details pane is now taking up the full width. And so since we only specified layout weight for the fragment container view, it will the details pane will take up the full width of the rest of the screen. So if we were to specify layout weight for the recycler view as well, so we give it the same weight as the fragment container view, we redeploy that, what we'll notice is evenly, even though it has the same weight, it's proportional to the layout width. So you notice that the recycler view is slightly bigger because the width is bigger. But in this case, we don't want to do that. We want the recycler view, the list view, to be a standard 550. So we are going to remove that and then redeploy just to make sure we didn't mess anything up. Okay, so in our case, we want the list view to always be at a max of 550 and then to be taken up by the details pane. Okay. Let's try to navigate to another item in the list view. So if we hit basketball here, notice that we are navigating to the fragment instead of opening it in the pane. So it's a little wonky, not the experience that we're hoping for. So what we can do is we can actually go to the sports list fragment file, and then on the view created, we can see the code which opens the fragment. So we're just going to comment this out, and then instead of doing this, what we want is to open the pane. So we're going to do binding sliding pane layout, open pane. So here we have this. Let's deploy this to the emulator again. Awesome, so here's our emulator. So let's select another item. The items are opening in the pane and not opening up over the sliding pane layout, which is perfect. This is what we want. So let's actually resize this to phone. So we can go back to the list view. We see all these items here. If let's select one of the items, the basketball, we're in this view. Let's say I want to go back to the list view, so I hit the back button. So I'm hitting the back button. So this is not what we want. We want to add custom back navigation. So when we are in the details pane and we hit back, we want it to go back to the list view. So for smaller devices where the list view and details overlap, sliding pane layout requires custom back navigation to navigate from the detail pane back to the list pane. So we're going to do this with the following two steps. First, we're going to define a custom callback to the back key press, which overrides the on callback. And the second thing is registering and adding the callback instance. So to define the custom callback, we are going to create a new class. So in the same file we were working with, the sports list fragment, at the very bottom, we're going to create a new class called sports list on back pressed callback. And then we are going to have a constructor parameter of sliding pane layout. Sliding pane layout. There we go. And we want this class to extend from the on back press callback, which handles the callbacks for on back press. So we're just going to extend on back press callback. And then notice we have an error here because it is expecting a Boolean value for enabled. So what we are going to do is set this as sliding panel layout is slidable, and sliding pane, not little s, not big S, little s, sliding pane layout is open. So basically what we're setting here is for is slidable, this will be true when the second pane is slidable and not side by side, which would be on smaller devices. The is open will be true if the details pane is completely open. So we want to enable it when it is not side by side and the details pane. So now that we've done that, notice we have another error here. So this relates to, we haven't implemented the handle on back press method. So let's go ahead and implement that. So here on the back press event, what we basically want to do is just close the pane. So we're going to do sliding pane layout, close pane, close pane. So great, now we have that done. Next, we're going to monitor the sliding pane events. So as the contents of the pane slides, we want to enable and disable the callback accordingly. So we're going to use the panel slide listener interface. And we're going to implement the interface's three methods: on panel slide, on panel opened, and on panel closed. So here we're just going to specify that this method extends the sliding pane layout, panel slide listener interface. And then we notice we have another error here where this is just saying we haven't implemented the method. So let's go ahead and implement these three methods that I mentioned: on panel slide, on panel opened, and on panel closed. So for on panel slide, we actually don't want to do anything. So we are just going to remove this to do, and we'll just leave that empty. So for on panel opened, what we want, so this that the details pane is opened and visible. So we want to set is enabled to true. So we will set is enabled to true. So when the details pane is open, we want to override the back button behavior. And then for on panel closed, this is the opposite, meaning that the panel is not open. So in this case, we want to enable set is enabled to false, which means we don't want to override the back button when the panel is closed. And then the last thing that we need here is an init block. And this is where we'll list the list of listeners that will be notified of the details pane slide events. So this will be sliding pane layout, add panel slide listener, and we're adding this. So great. Now that we have that, next we need to see our callback. To see our callback in action, we need to register the callback using the dispatcher pressed dispatcher using the following steps. So first, in the on view created method up here, we are going to create an instance for sliding pane layout. So sliding pane layout, and then we're going to assign it binding sliding pane layout. Great. Then second, what we're going to do is we will add the callback via the on back press back method. So what we do here is have require activity on back press dispatcher, add callback, and then we are going to pass in the view lifecycle owner and the sports list on back press callback, and then also pass in the sliding pane layout here. So this code uses the on call, passing the view lifecycle owner as an instance, passing in the view lifecycle owner and an instance of sports list on back press callback. So this callback is only active during the fragment's lifecycle. So this ensures that on back press callback is only added when the lifecycle owner is in the started state. The activity or fragment also removes register callbacks when their associated lifecycle owner is destroyed, which prevents a memory leak and makes it suitable for use in fragments or other lifecycle owners that have a shorter lifetime. So now that we've done all of that, let's test the behavior. So we will deploy this to our emulator. Okay, so we're back in our emulator here. So we click an item here, and then if we hit back, it should go back. That's awesome. So it's working as expected. So try. It's working great. So let's just go back to tablet to make sure that we didn't mess up anything on the tablet side either. So tablet is working as expected too. So we will go back to phone. So one thing that we can notice about the phone layout is you can actually swipe the pane away for the details pane. And so depending on your app, that may or may not be a desirable behavior. So in our case, we don't want the user to be able to swipe away. We want them to have to. So to change, to basically lock the pane from swiping, from the swipe gestures, it's a really easy thing to set. We just basically set the lock mode. So right here, after we define sliding pane layout, so we are just gonna set the lock mode to locked. So we do that, just one line there, and then we can redeploy this to see if it's working. In the emulator, so we click an item, we're in the details pane, If we hit back, if we try to swipe back, it doesn't go back. That went back because I was using the back gesture, which is like a back key button press. But if I just try to slide back on the pane, it doesn't slide back. So the back button still works, but you cannot slide away the pane anymore. So that's exactly kind of what we want, and is working. That was our last step. So congrats, we are done adding the sliding pane layout and making sure it works on smaller screen devices. There we have it. We've updated our app to implement an adaptive layout with sliding pane layout, and it now maximizes the available space on larger screen devices and behaves appropriately on smaller screens. We learned how to 1. Reconfigure our fragments for sliding pane layout, swap the detail pane in and out, handle custom back navigation, and disable gesture navigation between panes on smaller devices. So if you want to learn more about building for large screen devices, check out the resources in the description. Thanks for following along in this workshop, and I can't wait to see all the great adaptive layouts that you will build in your Android apps.